LEDs and lasers. What is an LED? In the simplest terms, a light-emitted diode is a semiconductor device that emits light when an electric current is passed through it. Light is produced when the particles that carry the current combine together within the semiconductor material. Since light is generated within the solid semiconductor material, LEDs are described as a solid-state devices. Term solid-state lighting, which also encompasses organic LEDs, distinguishes this lighting technology from other sources that use heat filaments or gas discharge. Different colors inside the semiconductor material of the LED, the electrons and holes are contained within energy bands. The separation of the bands determines the energy of the photons that are emitted by the LED. The photon energy determines the wavelength of the emitted light and hence its color. Different semiconductor materials with different band gaps produce different colors of light. The precise wavelength can be tuned by altering the composition of the light emitting or active region. LEDs are comprised of compound semiconductor materials which are made up of elements from group 3 and group 5 of the periodic table. Examples of 3-5 materials commonly used to make LEDs are gallium arsenide and gallium phosphide. Until the mid-90s, LEDs had a limited range of colors, and in particular commercial blue and white LEDs did not exist. The development of LEDs based on gallium nitride material system completed the palette of colors and opened up many new applications. So we can see main LED materials in these. Um, yeah. What about what is a laser? The letters in the word laser stand for light amplification by stimulated emission of radiation. A laser is an unusual light source. It is quite different from a light bulb or a flashlight. Lasers produce a very narrow beam of light. This type of light is useful for lots of technologies and instruments, even some that you might use at home. How does a laser work? Light travels in waves, and the distance between the peaks of a wave is called the wavelength. As you can see in the picture, top of the picture, and each color of light has different wavelength. For example, blue light has a shorter wavelength than red light. Sunlight and the typical light from a light bulb is made of the light with many different wavelengths. Our eyes see the mixture of wavelengths as the white light. You can see in the down of the picture. A laser a laser is different. Lasers do not occur in the nature. However, we have figured ways to artificially create this special type of light. Lasers produce a narrow beam of light in which all of the light waves have very similar wavelengths. The laser's light waves travel together with their peaks all lined up over one phase. This is why laser beams are very narrow, very bright, and can be focused into a very tiny spot. Because laser light stays focused and thus doesn't spread out much. Laser beams can travel a very long distance. They can also concentrate a lot of energy on a very small area. Um, Lasers have many uses. They are used in purification tools and can cut through diamonds or thick metal. They can also be designed to help in delicate surgeries. Lasers are used for recording and retrieving information. They are used in communication and carrying TV and internet signals. You also find them in laser printers, barcode scanners, and DVD players. They also help to make parts of computer and other electronics. What about differences between LED and laser? The significant difference between LED and laser lies in the working principle. LED emits the light as the consequence of charge carriers recombination across p-n junction, while laser emits light as a result of photons striking the atom and compels them to release their similar photon. A laser works on the principle of stimulated emission and LED works on the principle of electroluminescence. Thus, in laser, every released photon will strike another atom to release similar photon, and therefore the beam of light thus produced is coherent in nature. On the contrary, the light produced by LED is incoherent. Thus, light emitted by LED consists of many colors, while light beam generated by the laser is monochromatic, single-color light. LED is the acronym of light emitting diode, while the laser is the abbreviated term used for light amplification by stimulated emission of radiation. Comparison comparison chart. Parameters: working principle, LED electroluminescence, laser stimulated emission. Full form: light emitted diode. Light laser is light amplification by stimulated emission of radiation. Response: LED is slow response. Laser has fast response in comparison to LED. Driving current: LED has its range from 50 to 100 mA. Laser its range from 5 to 40 mA. Nature of emitted light: LED has incurrent and consists of various colors. Laser has current and monochromatic. Junctions area during manufacturing: LED has wide junction area, laser narrow and small junction. Um, Bandwidth range: lasers it lies in the range of 10 to 50 terahertz. Laser has it lies in the narrow range from 1 megahertz to 2 megahertz. Power to light conversion efficiency: LED approximately 20%, laser approximately 70%. Numerical aperture of the obtained light beam: LED higher in LEDs, laser extremely low as compared to LEDs. Numerical cost: LED has low cost and thus economical, laser high cost and thus used in the specific application. Key differences between LED and laser. First one is the light beam produced by LED and laser also creates a key difference between LED and laser. The light emitted by LED consists of various colors, while the light beam produced by laser consists of a single color. Second one is the working principle of LED and laser also created major differences. LED works entirely on the principle electroluminescence, which means illumination by means of electrons. On the other hand, laser works on the principle of stimulated emission. Another key difference between LED and laser is the junction area. The area of the junction in case of laser is extremely narrow, as light is allowed to pass from extremely small area. In case of laser, on the other hand, in the LED, the junction area is wider, thus light is allowed to pass through over the wide area. The concentration of charge carriers, such as electron and holes, are also different in LED and laser. In case of the laser, the concentration is very high, while in the LED is very low. Thus, laser is used in the surgical instrument in the medical field as it possesses sufficient energy that it can even cut the object contact with.